going to focus on solving polynomial equations strictly just by factoring. And then on Wednesday, we're going to get into how we can use synthetic division to solve polynomial equations. So the only extra thing we are adding is that step where we have to find the actual solutions. So if we have it in factored form, like if I had x plus 2 times x plus 3 is equal to 0, what are the solutions to that equation? -2 and -3, right? So if I can get something into factored form, we should easily be able to come up with those solutions. Yes? Yes, probably, hopefully. All right, so here we go. Let's start with this equation. 2x to the third minus 7x squared plus 3x equals 0. Is it a quadratic polynomial right now? No, it's not. It's cubic. So the first thing I should ask myself, is there a GCF? What is it? X. Let's factor out an x. So if I factor out an x, now I have 2x squared minus 7x plus 3 equals 0. Now do I have a quadratic? Yes, and we've spent a whole chapter learning how to solve quadratics, and one of those sections was based just on factoring. So let's see if we can factor it. 2 times 3 is 6. Factors of 6 that add up to 7. Yep, I'm going to make them both negative since it's a -7. My leading coefficient is 2, so I'm going to put it over 2. Reduce if I can. 1/2 does not reduce, but 6 over 2 does reduce to -3. What does that look like in factored form? 2x minus 1, perfect. What does the -3 look like? X minus 3. And we're going to bring down this x. So what are my solutions?
3, positive 1/2, and 0.
Right, so 3, 1/2, and 0. Whenever you have that x monomial out in front, you're going to have a solution of 0. So 0, 1/2, and 3. Notice what's the degree that we started out with. How many solutions did we come up with?
Wait, is that?
That should always be the case. Unless you get to something that has a multiplicity, like if this was squared and it's happening more than once, but it still should end up adding to 3. Okay? Questions with that? No? We're good? All right. How about this one? X to the third equals 49x. I like that idea. Let's get everything over, put it in standard form. So move that 49x over, so x to the third minus 49x equals 0. My degree of this polynomial is 3. That's your highest exponent. So that means I should have 3 zeros in my solution. GCF, x, take that out. So x squared minus 49 is equal to 0. How do I factor that? Yeah, so it would be plus 7 minus 7, right? It's a difference of squares. X plus 7, x minus 7, and an x equals 0. So what are our solutions? Good. X is equal to 0, -7, 7. Simple as that. Questions? Take out a GCF. Once you take out that GCF, it should take it to a quadratic. What if this whole thing was changed to a 4th power, and then we made this 2? Then what would the GCF be? Yeah, so then you would have taken out an x squared. We still would have gotten this, but now what would happen to the 0? You would technically end up with 2 zeros, right? which we use the word multiplicity. That means it's occurring twice. It's a multiplicity of 2 at the 0. If I were to graph this, it would only cross the 0 once. But because it's a degree of 4, we have to account for where that fourth 0 is coming from. Well, it's coming from 0 occurring twice. Okay? Got that?
So on like tests and quizzes, you want us to write 0 twice if that happens?
Yeah, or you can just make a note that says a multiplicity of 2,
Okay.
which we'll get to that. All right, so let's see if we can do this one. 15y minus 4y squared minus 3y to the third. Let's put it into standard form first. What should be the first term if I put it into standard form? The negative 3y to the third. Why do I not quite like the negative 3y to the third? Because it's negative. Well, we don't really like negatives. What would happen if I took all of these and moved them over here?
They would just change the signs.
They would change signs. Is everybody okay with us doing that?
Yeah.
So I'm going to move that over. I'm going to move that over. I'm going to move that over. Well, if you like negatives, that's fine. Just make sure then you factor out a negative GCF. I am. So that becomes a positive 3y to the third. It's going to become a positive 4y squared. And it's going to become a minus 15y. What's the GCF? Just y, right?
Yeah.
So take out a y. 3y squared plus 4y minus 15. Go ahead and finish that. See if you can factor it further.
Would you do 3 times negative 15?
Yes.
So that's negative 45. Oh, negative 5 plus 1. Never mind.
Check your work with mine when you get there. Yeah? All right. So we're good with that type of problem. The second type of problem we're going to learn for today, factoring wise, is called variable substitution. I like to call it U substitution because I use U as my variable, because U is a variable that doesn't get used very often in the variable world. So we're going to give it some love today. Technically, your book calls it variable substitution, but if you hear me say U substitution, that's what I'm talking about. So if I gave you the following equation, x to the fourth minus 4x squared plus 3. Is there a GCF for all three of those terms? No, there's not, right? Because that last term does not have a variable in it, so I can't take out any x's. So right now I have a degree of 4. Well, I only know how to factor things that have a degree of 2, if it's a quadratic. What can I do to the 4 to make it become a 2? Divide by 2, right? So watch this. If we let u equal x squared, I'm just making up a variable. I'm using variable substitution. I'm just picking u for my variable. So if I let u equal x squared, well, x squared to what power is x to the fourth? to the second, right? So then I can turn this into just u squared. Because x squared squared is x to the fourth.
Okay. Yeah, I follow.
U2?
u2. So what would this term turn into in terms of my u?
4u.
It would just be minus 4u
U2.
plus 3 equals 0. Now, do I have a quadratic?
Yes.
Yes. Can we factor that quadratic?
Oh,
Yeah.
Sure. Factors of 3 that get you to the negative 4. That's really easy.
-3,
-3, -1. So then I get u minus 3, u minus 1 is equal to 0. But my original equation didn't have u's in it,
Throw back in the X.
so let's throw back in that x squared.
We can do that.
So x squared minus 3, x squared minus 1 equals 0.
Does this make it harder? Make it easier?
Wait, why do you throw in the U?
Just to simplify the equation so my mind can think about factoring it
You
simply.
don't have like a 4.
Right, so I'm not, I mean, you could, if you see that 4 there, you could get right to this if you know this has to be squared, this has to be squared in order to get to a 4 when I multiply. But it kind of simplifies it.
Where'd you get the minus 1?
-3 and -1 makes -4. So now we have to find the zeros of those factors. Well, it's a little bit less, it's a little not as easy as last time. So before I could just say, what, 3 and 1? But now I have x squared and an x squared. So what are we going to have to do?
Make them equal 0.
Right, so x squared minus 3 equals 0. X squared minus 1 equals 0.
So we just square root both sides.
Yep, so get x squared by itself, so add the 3 over. So we get x squared equals 3. How do you undo a square?
Square root.
Square root it. Can I simplify the square root of 3?
No.
What do we have to remember when we use square roots, plus or minus?
Ew, I'm gonna forget that.
So I have a plus minus square root 3. What's this one going to be? Which the square root of 1 is 1, right? So that just becomes plus minus 1. What degree did we start out with?
4.
How many zeros did we end up with? Well, 4 technically, right? Because technically I have negative the square root of 3, I have negative 1, I have 1, and I have the square root of 3. Those would be your 4 complete zeros, right? If I were to graph this on my calculator, where would my x-intercepts be? Right there. Would it be hard to judge where the square root of 3 and the square root of 3 is, or negative square root of 3? Sure, it would. Okay? All right. I'm going to have you try one on your own, and we're going to bingo it up. Can I erase this? All right, so let's do x to the 4th minus 6x squared. Oh goodness, I just lost my train of thought.
24.
24, was that going to get me 6?
I don't know.
No. I'm going to have to do 12 would never get me 6. All right, let's change that 6 to a
36.
7, and we'll use that
I
12.
wrote a pen.
Sorry.
It's okay. Don't write a pen. No, it looks like that.
That should work, right? You know, we had a very good discussion about your excellent note-taking skills and how they're going to really follow through well in pre-calculus next year.
Well, it's working for me now, so. Oh.
So you don't have to use the variable substitution if you can see I need to go right to the x squared. Sometimes it just helps to simplify the equation and then go from there. It's just you have to remember to plug in the x squared back into place. And you can write your answer with those plus and minuses. You don't have to write out all 4 individually. Just know that those are 2 different things for each one. Did you get there?
Yep.